All right, welcome to The Explainer. Today we're diving deep into the microscopic marvel that, believe it or not, keeps your entire body in perfect balance. Get this. Every single day, your kidneys filter about 180 liters of fluid from your blood. That's enough to fill a large bathtub. Just think about that for a second. So the big question is, how on earth do they purify all of that fluid without you losing every single drop? Well, the secret lies in this tiny, super intricate structure and a really brilliant three-step process. Okay, let's dive right in. Okay, so inside each of your kidneys, there are over 1 million of these microscopic filtering units. They're called nephrons, and they are the absolute heroes of our story today. These are the fundamental little factories responsible for making urine. So each nephron is basically made of two main parts. You've got a filter, which is called the renal corpuscle, and then you've got this long, winding tube, the renal tubule. And it's inside that tube where the real magic of purification actually happens. Right, so the whole process kicks off right here, in the renal corpuscle. I want you to picture the glomerulus as this tangled up ball of tiny, tiny blood vessels. The blood pressure inside is actually super high. And that pressure is what forces water and all the small stuff out of the blood and into this little cup-like thing that surrounds it, the glomerular capsule. Okay, so as soon as that fluid, which, by the way, we now call filtrate, leaves the capsule, it goes straight into the first part of the tube, the PCT. And proximal is just a fancy way of saying it's closest to the start. This is a super important spot because it's the main place for grabbing back all those valuable nutrients the body definitely wants to keep. From there, the filtrate takes a trip down this long, hairpin-shaped turn called the nephron loop. Now, this thing is a master of water conservation. It actually dips way down into the inner part of the kidney, and in doing so, it creates this really salty environment that is absolutely crucial for pulling water back into the body a little later on. So, the DCT and the collecting duct, these are the final stops on the tour. And distal, yep, you guessed it, just means it's further away from the start. This is where all the final, delicate adjustments happen. We're talking fine-tuning the body's water and salt levels, and even its pH balance, making sure everything is perfectly balanced before that fluid officially gets called urine. Okay, so we've met the key players, right? We know the machinery. Now let's actually see them in action. This whole amazing purification process really boils down to 3 elegant steps. You've got filtration, reabsorption, and secretion. All right, first up, filtration. Let's just call it the first big squeeze. And really, it's a pure brute force process. There's not a lot of finesse here. It's just this powerful, non-selective squeeze that's driven entirely by your own blood pressure. The best way to think about it is like a high-pressure sieve. That force just pushes pretty much everything that's small enough to fit through the filter. We're talking water, salts, glucose, waste products, right out of the blood and into that tubular system. All the big stuff, like your blood cells and proteins, they get left behind. Okay, so filtration is super effective, but there's a catch. It pushes out a ton of stuff the body absolutely needs to keep. And that's where the real elegance of the next step, reabsorption, comes into play. And just look at the sheer scale of this step. It is absolutely mind-boggling. Check out these numbers. Your kidneys filter 180 liters a day, but you only pee out about 1.5. What does that mean? It means an incredible 99%. Yeah, 99% of the fluid and all those useful things that just got pushed out are carefully reclaimed and put right back into the blood. You can think of this as the body's ultimate strategic recycling program. As that filtrate is flowing through all those tubules, the body is using both active and passive transport to pull back all the essentials. Water follows salt because of osmosis, and all those valuable nutrients like glucose get pulled right back into circulation. Now, this is a really crucial point. This recycling system has a speed limit. It's known as the transport maximum, or Tmax for short. Think of it like this. The cells lining the tubule have these tiny little molecular gates, or transporters, right? And their job is to grab specific things like glucose and pull them back. But, and this is key, there's only a limited number of these gates available at any one time. And this gives us a perfect example of what happens when that Tmax is exceeded. In someone with uncontrolled diabetes, their blood glucose is just so high that all those little transporter gates get completely overwhelmed. They literally can't work fast enough to reabsorb all the glucose, so the excess just spills over into the urine. It's a condition called glycosuria. All right, that brings us to our final step, secretion. This is where the nephron performs one last, very important quality check on the blood. So secretion is basically reabsorption in reverse. Instead of pulling good stuff out of the filtrate, the body is now actively pumping unwanted stuff into it. It's targeting any leftover waste products, maybe some excess ions like potassium, or even drugs that might have been missed during that initial filtration squeeze. And really, this comparison is the key takeaway for these two steps. Reabsorption is all about your body taking back what it needs. Secretion, on the other hand, is about your body removing what it missed. One is for keeping the good stuff, the other is for actively ditching the bad stuff. So, filtration, reabsorption, and secretion. How do these three processes all work together in this continuous, perfect balancing act to keep our bodies in check? Well, this table really summarizes the whole journey perfectly. You can see how each part of the nephron is a specialist with its own job. The renal corpuscle, it's that initial brute force filter. The PCT gets right to work, doing the heavy lifting of reabsorption. Then, that incredible nephron loop masterfully concentrates the fluid. And finally, the DCT and the collecting duct come in to do that last-minute fine-tuning, making absolutely sure the final product only contains what the body truly needs to get rid of. And that's really the ultimate goal, isn't it? It's all about homeostasis. This constant microscopic dance of filtration, reabsorption, and secretion makes sure that the composition of your blood, your entire internal environment, stays remarkably stable, and that stability is absolutely essential for life itself. So this incredibly elegant process is happening millions of times over inside your kidneys, right this very second. It's fundamental to your health, which leaves us with a final question to think about. If the nephron's delicate balance is life, what happens when it gets thrown off? What lifestyle choices or medical conditions have the power to disrupt this vital function? And what does that mean for our overall well-being?